Hey everyone, we're going to go through the Moles and Stoich exam. I figured you guys can go through the multiple choice yourselves to try and figure them out. But it may help if I went through some short answer. So starting with question 21. A method used by ancient Egyptians to obtain copper metal from copper 1 sulfide ore was heating the ore in the presence of air. Later, copper was mixed with tin to produce a useful alloy called bronze. A 133.8 gram sample of bronze was 10.3% tin by mass. Determine the total mass of tin in the sample. Well, they give you a percent, and then they say this, by mass, percent by mass. That is your percent composition formula from your reference tables. So percent composition is mass of the part over mass of whole times 100. Here, they give me the percent. So I'd set it up 10.3% equals mass of the part, that's 10. I don't know it. Mass of the whole was 133.8. That was my whole. And don't forget your times 100. So to solve this, I need to first get rid of the 100. So divide by 100. That's gone. Got to do it on this side. Divide by 100. So I would get 0.103 equals x over 133.8. 0.8. And then when I solve for x, I'm really just multiplying because I'm going to go times 133.8 over here, cancel it out, times 133.8 over here. So it's really 138 times 0.103. And that gets you 13.78 grams of tin. I would think a biggest mistake was probably not doing this times 100. Next, I come here. Now this is a big problem, but I should really start paying attention to what the heck they're talking about, because what I'm noticing is you guys are not reading the questions. So let's go through and read what they're saying first, because it's for questions 22 through 24. So 3 questions are going to be on this. So it says, a hydrate is a compound that has water molecules within its crystal structure. The formula for the hydrate is CuSO4 5H2O, shows that there are 5 moles of water for every 1 mole of CuSO4. When CuSO4 5H2O is heated, the water within the crystals is released as represented by the balanced equation below. So this can kind of help you right now. They're talking about, oh, if it's a hydrate, it has water. Water's in the crystals. When you heat it, the water crystals are released. So it can help you for some multiple choice if you didn't know that. And here's the equation. And then this is the important part, because they're giving you lab data, so you got to pay attention up here. So the student first masses an empty crucible, heat-resistant container. They tell you what it is. The student then masses the crucible containing a sample of CuSO4 5H2O. The student repeatedly heats and masses the crucible and its contents until the mass is consistent. The student recorded the experimental data and the calculations shown below. So this is your student data. So it says, explain why the crucible contained sample in the given experiment must be heated until the constant mass is reached. Well, they're talking about up here that if I heat it, the water within the crystals is released. So if I'm coming to a constant mass, what I'm realizing is that all the water is gone. So the constant mass is to make sure all the water is evaporated. Very important. Okay, when I heat it, this is just like your lab that we just did. I heat it to a constant mass to make sure all of the water is evaporated, because if I'm comparing a hydrate to something anhydrous, no water. Hydrate with water. So then I look at question 23. So, let me fix here. Based on the given information, identify the total number of significant figures recorded in the calculated mass of CuSO4 5H2O. I do not know where the heck you guys were going, but total number of significant figures recorded in the calculated mass. If I read the question, they calculated the mass over here. So my calculated mass is right here of CuSO4 5H2O. It is 2.13. If I look at the significant figures, there are 1, 2, 3 significant figures. So 3 is your answer because the number is 2.13. You guys have to read the questions, okay? Recorded in the calculated mass. Gotta pay attention. 24. Again, we weren't paying attention. Use the student's data. That's how this question starts. Use the student's data to show correct numerical setup for calculating the percent composition by mass of water in a hydrate. So numerical setup, I don't have to solve it. I have to calculate the percent composition by mass. That brings you to table T. To grab the equation we used before, mass of the part, mass of the whole times 100, but I need the student's data. So if I'm finding the percent water, here's what I need. I need to go back over here. I need to notice that this is my mass of the hydrate. This is my mass of the anhydrous. And when they got the water, look, they subtracted hydrate minus the anhydrous. They got this mass of water. So this is my water. So if that's my water, this was my hydrate. This is my part. This is my whole. So I get, right here, 0.76 divided by 2.13 times 100, and that's all I have to do. I don't have to solve it. But again, I'm using the student's data. That's the really important part. Then here, determine the gram formula mass of stearic acid. I think gram formula mass you guys are pretty good with. You're just going to add up the masses of everything. So I'm going to say, okay, there's 17 C's. C is a mass of 12, so 12 times 17. Plus there are 35 H's. H has a mass of 1 times 35. Plus, I see another C. I could have done that over here, but I'll do it again here. 12 times 1. Plus, I see 2 O's right there, so 16 times 2, plus another H, so I'm going to make sure I grab that. Again, I could have put this C and this H in over here, but it doesn't really matter. So when I do that, I get, well, let's see, 12 times 17 plus 35 plus 12 plus 16 times 2. Close my parentheses, equals plus 1, 284. Gram formula mass, grams or grams per mole. 26. Here again, we went awry here. Let's read the problem. The compound 1,2-ethane-diol can be mixed with water. This mixture is added to automobile radiators as an engine coolant. The cooling system of a small van contains 6,690 grams of 1.2 ethane diol. Some properties of water and ethane diol are given below. I'd go up here and I'd probably grab this number. They tell me I have that much ethane diol. So really what they're doing is they're giving me a mass. Let's see if I need that. Let's look at the question. So I see the table, gram formula mass of water, gram formula mass of ethane diol, and they give us the boiling point, but you're not really going to need the boiling point for this. So it says, using the given information, calculate the total number of moles, 1,2 ethane diol, in the small van's cooling system. I need the numerical setup and the calculator result. So if I look back up here, if I'm trying to find moles, well, here's my gram formula mass for my ethane diol. Here's my given mass up there. Remember, moles, again, table T. Grab that equation, moles equals your given mass over your gram formula mass. So my mass was 6,690. Gram formula mass, 62. And when I do that, I get 107.9. Didn't say anything about sig fig, so I didn't have to do that here. I was solving for moles. If I wanted to do sig figs, I probably remember I said don't use the mass. I'd want to go up here. That would be 3. So I did accept if you wrote 108. I'd prefer you just left it if they don't tell you to do that. But either or, same thing. This is the one I prefer, but you could have told me that too. Okay. Oh, back to there. Let's go to question 27. All right, question 27. Some dry chemicals can be used to put out forest fires. One of these chemicals is NaHCO3. When NaHCO3 is heated, one of the products is CO2, as shown in the balanced equation below. So I see, I take this, I heat it, I get this and this and this. This would be a decomposition reaction. I do see CO2 in water, not combustion though, because there's no O2 here. So this is decomposition. Here it says, determine the total number of moles CO2 produced when 7 moles of NaHCO3 is completely reacted. Well, if I look up here, normally it has a ratio of 2. And then I look at moles CO2, there's nothing there. It'd be a 1. So normally it's a 2-to-1 ratio. So if I now have 7 of this, and I don't know how much I have of this, I'm setting up my ratio. 2 over 7 equals 1 over x. What they gave me originally over what they're asking me to change it to. I cross multiply. 2x equals 7. Divide by 2, divide by 2. X equals 3.5 moles. This is stoichiometry. All you're doing is looking at the ratios to decide. I normally have 2 for every one, so if I normally have 7, well then I'm going to have 3.5 of these. You can do it in your head, or this is the proportion way that always gets you the answer. 28, determine the mass of 5.2 moles of C6H12, and they give you the gram formula mass of 84.2. So they're telling me to find a mass. I have moles. They're giving me gram formula. This is definitely mole equation. Again, table T. Some of you aren't going there, and you're putting it times 100. It's not times 100 on table T. It says moles equals your given mass over your gram formula mass. So use that equation. So I know that I have 5.20 moles, and that equals my mass. I don't know. I'm solving for it, but I do know that the gram formula mass is 84.2 grams per mole. Again, to solve that, I got to get that x. I end up multiplying these two things, And I'm going to get X equals, let's see, 5.2. Right, 5.2. Yep, 5.0 times 84.2. And I get 437.84. That's a mass. It'd be in grams. Again, it didn't say anything about significant figures, so I would just leave it if I were you. But technically, there would be 3 sig figs here. They technically use 3, but again, they rounded a little bit, so I'd go off of here. Oops, my lights went off. Hold on. So technically, if you wanted to round this to 438, you could, but I'd just leave it like that. Okay. 29. An unsaturated solution is made by completely dissolving 20 grams of NaNO3 in, they're putting it in 100 grams of water. Show the numerical setup for calculating the number of moles NaNO3. They give me a gram formula mass used to make the unsaturated solution. So you don't know about saturated and unsaturated solutions yet, but you don't need to. They asked right here, the moles of NaNO3. They gave me a mass right here, given mass. They want me to solve for moles. They gave me a gram formula mass. So again, this equation, moles is given mass over gram formula mass. So moles equals given mass 20 .0 over 85.0, and they just wanted the setup. So that's it. I'm looking for 20 over 85. Units or no units, that's what I wanted to see. Question 30. Given the balanced reaction or equation representing a reaction, determine the total number of moles of oxygen that reacted completely with 8 moles of C2H6. Again, I'm not going to go use this equation because I don't see them giving me any masses. All they're talking about is moles. So if they only give me moles, this is stoichiometry. Looking at the ratios. So I'm going to look and say the total number of moles of oxygen. Okay, here's oxygen. Here's what I want to know. So that's X. React completely with 8 moles of C2H6. So that's 8. It's normally a ratio of 2 to 7. They're asking me to change this to an 8. So what does this change to? Set up a ratio. 2 over 8, original over what I'm changing it to, equals original over what I'm changing it to, 7 over X. When I do that, I cross multiply. 2x equals, I should really know this, but 8 times 7. Yep, 56. Just want to make sure. And divide by 2. Divide by 2 gets rid of that. So x equals 28. And it's moles of technically oxygen. So O2, 28 moles of oxygen. 31. Determine the total number of moles CH3Br in 19 grams CH3Br. See how this is different? They're asking me to solve for moles and they're giving me a mass. Now I go back to my mole equation. Again, one more time. Mole equation, table T. I have what I need. So moles equals given mass is 19 over gram formula mass. They were nice, gave it to us 95. 19 over 95. 0.2. 0.2 moles. Last couple. Again, I better read up here to see if I need anything to solve these. It says both of these are refer to here. So I know it's a lot of reading, but read it. Read to make sure that you get all the information you need. So it says a portable propane tank or portable propane fueled lantern contains a mesh silk bag coated with metal hydroxides. The primary metal hydroxide is yttrium hydroxide. When the silk bag is installed, it is ignited and burned away, leaving the metal hydroxide coating. The coating forms metal oxides that glow brightly when heated to a high temperature. During the test, a propane lantern is operated for 3 hours and consumes 5 moles of propane from the lantern's tank. The balanced equation below represents the combustion of propane. Propane, presence of oxygen, combustion breaks into CO2 and water. So here it says determine the total number of moles CO2 produced during the lantern test described. They described it to you up here. During the test. So during the test it consumed 5 moles of propane. So that is of the propane though. Okay? So they're saying it used 5 of that. Normally, it would be a 1, but it's a 5. This is stoichiometry again, setting up a ratio. If I want to find the moles CO2, I say, okay, I don't know this. Again, originally it was a 3. Originally it was a 1-to-3 ratio, so now it's 5. So what is this? So 1 over 5 equals 3 over x. Cross multiply, x equals 15 moles of CO2. Stoichiometry. 33. Calculate the total mass of propane consumed, again, during the lantern test. So they want a numerical setup and a result. They want the mass. And I think, well, what do I go to? Again, 5 moles. 5 moles of it was consumed. So you're using your mole formula, table T. Moles given mass, gram formula mass. They told you 5 moles equals given mass. You don't know. You're finding it. X. I need it over the gram formula mass of propane. So I got to find my GFM. So GFM of the C3H8 is 12 times 3 plus 1 times 8. 12 times 3 plus 8. 44 equals 44 grams per mole. Put it over 44. There's my setup. 5 moles equals X over 44. Technically, that's grams per mole. Solve for that X. You're multiplying again. So 5 times 44. 220. You solved for a mass, so it's in grams. Biggest thing you guys aren't doing is reading. You really need to be careful about what are they giving me and what am I solving for. I hope this helps you. Make sure your corrections are done. Apply this to some of your multiple choice questions. And we're going to revisit this sometime soon. Thanks.